In this video we review the basic features of the AutoCAD Hatch command. This video specifically references the graphic interface of the Hatch command in AutoCAD MAC version. Hatch is an AutoCAD-specific term, which simply means to shade. The architectural term often associated with Hatch is poche. The Hatch command adds patterns to floor plans, walls, and detail drawings to add clarity to the object it references. In this example, the hatch pattern helps to provide meaning to the flooring material for the interior design. In this example, the hatch pattern provides very specific definition to the type of wood grain used on the cabinet panel. These two examples show very different methods of constructing the recessed cabinet panel of a framed cabinet style. Finally, solid hatching is often used to fill in the exterior wall lines on floor plans to add visual hierarchy and clarity. In the example shown, there are 4 rectangles set up to demonstrate different aspects of the hatch command. Adjacent to the rectangles is a plan view layout for practice shading walls and floor areas. Let's get started with an introduction of the hatch command and the specialty dialog boxes that help define hatch patterns in AutoCAD MAC. At the command line type, hatch, return Enter key. This command deploys the dynamic hatch dialog band in AutoCAD MAC, located at the top of the drawing environment. From the Hatch dialog band, locate the Select Boundary icon. Boundaries are the most important aspect of creating a hatch pattern. On this panel you have the option to select a boundary, or to pick inside a defined area. Locate the pattern icon on the Hatch dialog band. From this pull-down menu of options, you can visually see examples of different pattern types. This panel will dynamically change and update to offer different shading options, as you make choices within the general categories of hatch. From the pull-down menu you can choose solid shaded fill types, gradient fills that mix 2 colors together, and user-defined hatch patterns. User-defined hatch patterns are those that are purchased from third-party vendors and have been installed to be used with the hatch command in AutoCAD. Adjacent to the pattern panel is the hatch angle feature. This icon sets the angle of orthographic style patterns within a specified area. Hatch angle is not relevant when using hatch solid fill types. Adjacent to the hatch angle icon is the hatch scale feature. This icon sets the size of the pattern repeat within a specified area. Setting the hatch scale is critical to the graphic understanding of the pattern within the specified drawing. We are now going to practice the hatch command in the 4 rectangles. In the first rectangle, choose a hatch pattern such as the net pattern. From the pull-down menu, scroll down to find the net pattern. From the Hatch dialog band, choose the Select Boundary icon. This means that we need to pick the rectangle as the boundary. As soon as I pick on the rectangle, Hatch fills the area, but it doesn't look like the net pattern. Why does it look like a solid fill instead of a pattern? The answer is that the pattern scale is so small that it appears as a solid fill instead. There are many patterns such as net in AutoCAD Hatch where you will need to increase the pattern scale in order for it to make sense in the drawing. Let's increase the scale to 12 and then the return key to accept the new value. This action increases the scale to what we might perceive as a full increment in the imperial system of 12 inches equals 1 foot. 12 is always a good starting point for increasing the scale. Since the pattern is still too small, the next increment I will try is times 10. I will change the scale value to 120 and then pick on the return key. This now appears to be more recognizable. We have now made an industrial design hatch pattern into something we can use in interior design. This somewhat resembles a tile pattern. If we were using this hatch pattern in a room, we would want to reset the origin point of where the first whole tile appears in the space. To do this, type at the command line, hatch edit, return. Now pick on the hatch pattern you just created. The hatch edit dialog box will appear. There are a lot of features to consider in the hatch edit dialog box. It is worth our attention to take a quick tour of the editing options. In the Boundaries category there are 2 add options, Add Pick Points and Add Select Objects, followed by Remove Boundaries and Recreate Boundary. The Display Boundary option is useful when you need to see a boundary, but in the instance where you may have created the hatch pattern on the fly without a boundary originally. We will not be covering this feature in the basic hatch video. Directly below this area is the Options category. In this area, you have the option to make the hatch pattern as annotative, which means AutoCAD will adjust the repeat pattern scale as you add viewports to the drawing. Associative, which means that the hatch pattern will be an editable group. This feature enables the hatch to automatically update as the boundary becomes redefined. The last feature in the options category is separate hatch. This is useful if you have one large hatch pattern that needs to be broken up into smaller areas. The draw order feature is an essential tool. For example, when using hatch, the pattern will sometimes appear on top of wall lines. Since the wall lines have the greater priority in the visual hierarchy, the hatch needs to be moved below the wall lines using the draw order command. You can also reassign the layer definition and the transparency of the hatch pattern. Pick on the layer pull-down menu to reassign the hatch pattern to the following. A floor pat. Layers are an important way to control how we view the hatch pattern and must be located on a unique layer such as those defined in the AIA Layer Standards handout. In the middle top area of this dialog box, we can change the hatch type, pattern, hatch color, background color, angle and scale. Below these general hatch definitions is the hatch origin category. Instead of the assignment, use current origin. Pick on the button next to it. Click to set new origin. The hatch edit dialog box will momentarily disappear so that you can reselect the new origin point of the hatch pattern. Pick in the lower left-hand corner of the first rectangle to reset the pattern origin. Pick the OK button in the hatch edit dialog box to end the command. This puts the first full pattern in this corner. Notice how the pattern instantly realigned to that point. To prepare for the next part, change the current layer to a wall pattern layer. The reason we want to change to this layer is that, in architectural drafting, the exterior walls are often filled with a solid hatch. The layer most often associated with the solid hatch is a wall pat and color number 253 or color 254, which are both screened index colors in the Monochrome.ctb pin assignment, which we will discuss at the end of this video. The top right rectangle will be filled with a solid hatch. At the command line, type hatch, return key. From the hatch pull-down menu, pick on Solids. Next, from the hatch band, pick on the Select Boundary button. Pick on the top right rectangle. Choose the return key to accept the hatch pattern. The next rectangle will feature the gradient hatch fill. To prepare for the gradient pattern, make the generic hatch layer the current layer. Make note of which index color is assigned to this layer, which is color number 9. Begin the hatch command. From the hatch dialog band, pick on the pattern drop-down menu and choose Gradient. Choose the linear gradient pattern. Pick on the Select Boundary button on the hatch dialog band. Pick on the lower left-hand rectangle. To change the gradient mix, go back to the Gradient dialog band and pick on the top color box. From the Color pull-down menu, choose the Select Color to change the first gradient hue to any other color. Pick on the True Color tab at the top of the Color Palette dialog box. Pick anywhere in the color spectrum to select a new color. Pick the OK button. This changes the first gradient color. Repeat the process for changing the second hue of the gradient mix by picking on the second color box. Choose the Select Color option from the pull-down menu. Pick on the True Color tab at the top of the Color Palette dialog box. Pick anywhere in the color spectrum to select a new color. If you prefer to change the level of saturation, pick on the Saturation slider here. Pick the OK button. This changes the second gradient color. Next, locate the angle for the gradient and type in 45. Then pick on the return key to end the hatch command. For the final rectangle in this series, you will need to make the floor pattern layer the current layer. Again, notice the color assignment for this layer, which is color number 254. At the command line, type hatch, return key. From the pattern pull-down menu, choose Hatches. Locate and select the Dolmet pattern from the alphabetical list. This pattern somewhat resembles a wood plank flooring pattern. pick on the Select Boundary button on the Hatch dialog band. And then pick on the lower right rectangle. A common plank width is 8 inches. Let's see how the Dalmat pattern in rectangle number 4 compares to this standard by measuring the distance between the plank lines. It is difficult to measure the exact size of the planks because the pattern is associative in nature, meaning it is a block of information. To be able to make an approximate measurement using the distance command, toggle off the OSnap F3 button for a moment. Zoom up close on the hatch pattern. Use the distance command to pick 2 points for an approximate measurement. This does not have to be exact because we will also specify on the drawing the procurement of 8-inch planks. At the command line type, Hatch Edit, return Enter key. Pick on a line of the Dalmat pattern in rectangle number 4. The Hatch Editor dialog box is deployed. In Hatch Editor, you can see a variety of different options which you can use to modify an existing hatch pattern. You can even change the pattern within this dialog box, if needed. However, we just need to reduce the scale down to 32. Pick the OK button. Take another measurement of the planks using the distance command. This time the plank width is pretty spot on to the 8-inch pattern repeat required. Let's use the information covered in this tutorial to create hatch patterns in the sample floor plan in this practice assignment. The next example illustrates the process of applying the Dalmat pattern to the plan view drawing using the Hatch and the Match Properties commands. The first critical aspect of this example that requires attention are the openings between the wall lines, where doors and windows would be located. The Hatch command creates a repeatable pattern only when there is a closed boundary. Any open spaces will create an error using Hatch. To prepare the plan view for Hatch, make sure the A-floor pat layer is current. Next, use the line command to make a boundary by picking on the interior side of the wall lines using the OSnap endpoint. Go around the entire plan view, closing all gaps and openings. This is an essential tip when using the Hatch command in drawing views, such as floor plans. Once the plan view is prepped for a hatch pattern, pick any pattern from the Hatch Pattern panel. Since we are matching the pattern to the existing Dalmat hatch in rectangle number 4, it doesn't matter which hatch pattern we initially apply here. From the Hatch dialog band, we are going to select Pick Points. This selection method works by picking on an interior point of an area of a closed region. As soon as you pick the interior point, AutoCAD fills the area with the pattern until it hits each side of the boundary. Go to the Modify pull-down menu and choose Match Properties. Then, pick on the Dalmat pattern in rectangle number 4. Next, pick on the pattern inside the plan view drawing. The pattern should now match the Dalmat pattern in scale from rectangle number 4. The last example of using the hatch pattern involves shading the exterior wall lines using the solid hatch pattern. To prep the walls for the solid hatch, make the A-wall pat layer the current layer. Again, note the index color assigned to this layer, which is color number 253. It is essential that all of the wall lines be connected so that each section of the wall is a closed region. If any part of the wall lines do not connect, the hatch pattern will denote an error. Start with the Hatch command. Locate the solid fill on the Hatch Pattern panel. On the Hatch Boundaries panel, use the Pick Point selection tool. Zoom up close to the wall lines, but make sure you can see the entire closed wall area on the screen. Hold the spacebar on the keyboard to pan around in the drawing while maintaining the close zoom distance. When all of the exterior walls have been filled with the solid hatch pattern, pick the return key to finalize and end the hatch command. The next part of the video is a review of the multi-view command. We will also demonstrate how to customize a block title block with attribute text and create a customized pen assignment to create the right shading of the various hatch patterns. Pick on the Paper Space tab entitled 11 by 17, located in the lower, left-hand corner of the drawing environment. On the paper sheet, we will create 2 individual viewports, set at different drawing scales. To get started, make sure the current layer is set to a non-plotting layer, such as def points. To create each viewport, utilize the multiview command as you see me do here. Pick 2 points on the screen to create a rectangular viewport using the multiview command. You will see that the viewport fills with the entire model space group of objects. To isolate only the practice rectangles, double-click inside the viewport you just created. You can tell you are in floating model space because the viewport line is accentuated with a heavier line. Use the zoom command or your mouse to zoom in closer to the rectangles, leaving out the floor plan information. Utilize the pan-hand feature, if needed, by holding down the spacebar on the keyboard. Once you have the rectangles inside the viewport, double-click outside of the viewport area to deselect floating model space. You are now back on the paper sheet. We now need to scale the viewport. To do this, grip the viewport line by picking on it once. You should now see the viewport scale located in the bottom right-hand corner of the drawing environment. Choose the 1/4 inch scale from the menu of choices. To deselect the viewport, pick the Escape key on the keyboard. We will repeat the multiview command to create the viewport for the floor plan information only, this time leaving out the practice rectangles. At the command line, type MV for the multiview command, followed by the return key. Pick 2 points on the screen to create a rectangular-shaped viewport. Activate the viewport by double-clicking inside of it. Use the zoom command to isolate the floor plan information only. Double-click outside of the viewport to deactivate floating model space. If the viewport lines are now back to a thinner line weight, you are back on the paper sheet. Grip the viewport rectangle by picking once. Set the viewport scale to 1/8 inch equals 1 foot. You may need to adjust the viewport rectangles to make them fit on the paper sheet. You can do this by gripping the viewport and dragging out the blue boxes at the corners. To deselect the viewport, pick the Escape key on the keyboard. You are now ready to fill in some of the title block information. Part of the title block must be accessed through the block editor. To do this, grip anywhere on the title block and right mouse click. Choose Block Editor from the mini menu. You will recognize the block editor from an earlier lesson modifying cabinet blocks. Within the block editor, erase the placeholder for the logo. If you have a logo, try to fit it within this space. If you have not yet created a logo, leave this area blank. Edit the text by double-clicking on the text placeholder. Pick the Save button to see if your name needs any further adjustment. If your name does not fit, go back into the block editor to adjust it. To edit the title block text, double-click on any of the attribute text seen here. This will bring up an attribute text editor box. Highlight the date. In the value field, erase the placeholder text and fill in the current date. Highlight the initials category, and in the value field, type in your initials in all capital letters. Where drawing scale is indicated, it is appropriate for the title block to state, as noted, since there are multiple drawing views shown at different scales. The project number is typically defined by the year of the project, followed by the client number. For our purposes, the client number will reflect 100. For this assignment, there are no other modifications to the title block, since there is no client information to fill out. Pick the OK button to end the Attribute Editor dialog box. The final part of this video addresses how to assign screen pin assignments to the index colors defined on the hatch pattern layers. Recall that these layers were assigned index colors number 9, number 253, and number 254. To access the Monochrome CTB pin assignment, you will need to deploy the Print dialog box. On a Mac, this is the Command-P key combination. Alternatively, you can go to the File pull-down menu and select the Print option. For this assignment, a PDF plotter has already been assigned to the layout. In addition, a Monochrome CTB pin assignment has been assigned as well. Adjacent to the Monochrome definition, there is a pin assignment button. Pick on it. You should now see all of the AutoCAD index colors listed here. First, locate and highlight color number 9. On the right-hand column, locate the field entitled Screening. It currently reads as 100%. This means that anywhere color number 9 is assigned in the drawing, it will currently print as pure black. Instead, highlight the 100 and replace this value with 45. Scroll down to index color number 253. This is the color assigned to the layer with the solid wall fill hatch. This should be a screened index color as well. Highlight the screening field and replace the 100 with the number 60. Finally, choose index color number 254. This is the color assigned to the flooring layer. The flooring should be set to a screening of 25. Pick on the Save and Close button. From the Print dialog box, choose the Preview button. You should now see a hierarchy of visual information displayed throughout the drawings. Pick the Save as PDF button to save the printed document as a PDF. Note, the gradient hatch still denotes color, even though this is a monochrome pen assignment. This is because the true color pens were utilized instead of index colors. True color assignments for items such as company logos and rendered features is a way to strategically define limited color while maintaining the industry standard black lines and gray shading that is part of the architectural professional drafting standards for drawings.